Good afternoon and welcome to everyone who's joined this webinar. On behalf of FOPE, Federation of Pharma Entrepreneurs, and PhD CCI, Chamber of Commerce, PhD, and the Tube Promotion Council, I welcome you all to this learning and discussion webinar series, Zero Contamination Squeeze Tube Manufacturing. This is a new technology and we thought it best that we should have a demonstration of the technology followed by a discussion. So in order to start the proceedings, I would like to invite Mr. B.R. Sikri, who is the chairman FOPE, to make an inaugural address. I just make a brief introduction, though he may not need any introduction with the audience here, but Mr. Sikri is the chairman FOPE. He's the vice president, Bulk Drug Manufacturers Association, BDMA. He's secretary, Indian Drug Manufacturers Association. He's advisor, Himachal Drug Manufacturers Association, president, Pharma Indenting Agents Association. He has over 42 years of rich experience in various sectors, including more than 24 years in the pharma sector. The expertise covers logistics, supply chain, sourcing, purchase, marketing, and indenting. So after working for the Haryana government, central government, he worked with FACT, a public sector undertaking under the Ministry of Fertilizers and Chemicals. Thereafter at SOL Pharma, he was vice president and he managed the regulatory affairs, marketing of bulk drugs, export to CIS countries, and joint venture project in Vietnam. He is associated with a number of world-leading pharma ventures as a promoter and an entrepreneur. So I'd like to invite Mr. Sikri to make an inaugural address, after which we will all go to, we will move to Mr. Bhatia and then we will go to Bulgaria. So Mr. Sikri.
Thank you. Am I audible to everybody?
Yes, you are
Yes,
audible.
sir. Yes.
Thank you. Thanks for my exhaustive and vivid introduction. I, on behalf of FOPE stands for Federation of Pharma Entrepreneurs, and on my own behalf, welcome you all in the knowledge-based technical webinar. This pandemic has brought some new opportunities to our industry and side-by-side few challenges also. Before I come to technical area of this concept on which webinar is going to be organized, I would like to bring it to the kind notice of all the delegates that our industry is a knowledge-based industry. And there is no shortcut in our industry. Somebody said that where there is a wisdom means knowledge. Where there is a wisdom, there is a science. And where there is a science, there is a prosperity. Whichever country is prosperous today, maybe US, Germany, France, Japan, Australia, these people have converted their wisdom into science and they become prosperous. So India is also moving towards that direction. And today's webinar is also talking about the science, innovation, research. Now, as all of you are aware, India started developing new regulatory institution with the introduction of reform somewhere in 1991. Now that process is going on. Now with any new change coming to our industry, we are always ready to accept with an open mind so far as it is having this scientific backing. So in today's webinar, Mr. Praveen Bhatia discussed with me a couple of times. I wanted to understand what exactly is the concept. Is it going to be only a marketing concept or is it really involving science? When I got convinced, yes, there is a brain applied behind this machinery. See, for example, tube. Normally we pack it in a corrugated box. Corrugated box has the future of having some particles. Either they will have paper particles or microorganisms. So to avoid that particles, they have developed this new concept and new idea and new innovation. So with that introduction, there's a saying that there's a necessity. Necessity is the mother of invention. So it is with that motive, Bulgarian company did some invention, some innovation, as well as research and brought the solution of this problem. They are claiming that you can make tube in-house to overcome contamination problem and dust particles and microorganism also. So this can be for pharma sector as well as it can be for food application also. Mr. Mirosia from Bulgaria is going to demonstrate the machine He is going to explain his technology. He is also going to show the operation. So once the demo is over, all our members, whether you are from FOP or any other association member, have got question answer session, and a lot of technical people are involved. I'm happy that more than 40 people have already joined, and by the time the demonstration starts, we are going to cross 50. So I'll be grateful. I'm grateful to Mr. Naveen Seth, who is the principal director of PhD, who is not there, but his involvement is there. And my old-timer friend, Mr. Ashok Bhatia, ex-Zydus Kedila, Mr. Rahul Bhargava, Mr. M.K. Banerjee, and incidentally, I was the chairman of healthcare committee of PhD last year. So I'm grateful to Mr. Praveen Bhatia, who took this lead and arranged this technical webinar. We will have ample opportunity to have similar type of program in the future also. As I discussed with Mr. Praveen Bhatia, our working president, Mr. Vinod Kilani, a dynamic technocrat who knows the regulatory system also, who knows the intricacies also, who knows the technology also. At the end, on behalf of FOP, he will be extending the vote of thanks, and he will also be giving the concluding remarks. So over to Mr. Praveen Bhatia. And one remark I would like to give Praveen Bhatia ji. Many people ask me what Mr. Praveen Bhatia organization has contributed to FOP. I said he's contributed only goodwill. When the machine starts selling, we will ask him to sponsor one of our annual events of FOP. So with his stands committed. Thank you.
Thank you.
Over to Mr.
Thank you.
Praveen Bhatia.
Thank you, sir. Thanks a lot. And thanks to everybody who spared time to joining this seminar. And starting with, I will commit with whatever you told. I will commit the statement. I will sponsor one of the seminars of the FOP if once the things will start moving on. And I'm very thankful to Mr. Sikri. You are always very helpful to me, and you always given good advice to me during all of my career. This this process, most of our tube manufacturer think that we are replacing them. First of all, I'll start with this small introduction of this machine. Then later on, naturally, my colleague Miru will explain this technology. Here is, we are not replacing any tube manufacturers. Here is for the pharma people who want to go for a short runs and start a new product, a new venture into the new items. They can do their in-house, and they can do with the short runs and avoid all hygienic and other things. So this particular, there's no threat to the tube manufacturers. Pharma company will remain by the tube from the tube manufacturers, remaining for the bigger, longer volumes, big volumes and all. This is for basically coming out with the very sensitive product which they don't want the contamination should be there in this scenario and all. So that's why I wanted to start with this. And ultimately, our idea is in a tube promotion council to give it new and new ideas so you can pack the products in a tubes. Now, I will take you to Bulgaria. And because of the travel restriction of everything, we are not going to Bulgaria, but let's move to Bulgaria. Screen, Indrajit, put the screen there, yeah. I just made up a small presentation of Bulgaria where you can see this is Bulgaria is an Eastern Europe country where this is a map of Bulgaria. Bulgaria where the capital is Sofia. There's a lot of places you can visit in Bulgaria. Bulgaria is officially country of the Eastern Europe, and it's bordered to Romania, Serbia, North Macedonia, Greece, Turkey, and the Black Sea on the east. The capital is Sofia. And there's a lot of good cities are there. And this is famous in natural diversity and mountains and other things. The total area is 110,994 square meter. And the population is only half of Delhi, maybe less than Delhi, is 7 million. And the currency is leva. This leva is €1, 2 leva is €1, something like that. And this is a sightseeing of Bulgaria. So at least you cannot visit, but you can have some feeling of Bulgaria. There's a good sunny beach there. This is the traditions traditional instrument of Bulgaria. There's a Bulgarian dresses, and the famous food. The famous food is whenever I go to Bulgaria, there's a there's a yogurt lassi which we drink. There's very famous is there is in Bulgaria also. They drink a lot of buttermilk. They call buttermilk. They drink a lot of buttermilk there. And next, yeah, this is a place where our mechatronica is there. Gabbro is a small province. It's a total population is only 130,000 people, and 48% is male. And it's very small capital and 200 kilometers from Sofia. And there is factory. Now, Miru, over to you. So we taken you to the factory. Now, Miru, you can start your presentation.
We can make a small introduction about Miru.
Yeah.
A brief introduction about Mr. Miroslav Hinkov. He's the managing director of Mechatronica, popularly known as the Combis. He is a brain behind a lot of innovations in the tube industry. Mechatronica was established in 1961. The company specialized in solving complex technological problems in the machine building, electronics, food, and chemical industry, which is their expertise. Companies like Unilever and Huhtamaki asked Mechatronica to work on development of a machine of their interest. The FFS 60, which we will be talking about, is one such development where Unilever asked Mechatronica to develop an in-house filling and tube body making machine. The objective was to reduce carbon footprint, reduce cost of tube packaging, and provide a solution for short-run jobs. While working on the project, Mr. Miroslav not only completed the above objective, but also offered features like reduction of wall thickness of the tube. Today, Unilever has installed these machines in various Unilever factories world over. So with that introduction, we move to Mr. Miroslav.
Thank you. Thank you very much. I hope you hear me. Do you hear me?
Yes.
Yes.
Because it's really a little bit noisy here. Okay, so thank you for presentation of myself and also for my country. I would like today to present you one real machine which is running in real environment, production environment. I think this is best way to present this technology. Unfortunately, in our company, we don't have at the moment running machine. So I went to one customer we have in Bulgaria. It's a little bit far, but they are running 6 machines, FFS type, and some of those are already 3 years in production. So I think this will be really, really good for you to see. So I will now switch my camera. Go a little bit close to the machine. First of all, from here, you may see this is more or less the whole setup. Starting with those tanks which are on the side, they supply product from the tanks. Then, okay, you see this pipe, and then they have pump, which is providing product. In this case, this is kind of cream they are filling to the machine. So I will go and just start from another side of the machine. First, here we have pre-molded heads, as you see heads. They are putting them in a bulk. Then, with this giraffe, they are supplied to the ball filler.
Miru, let's see the camera a little bit. Not there. The pictures are not getting clear. Put the camera right. I think we are not getting a good camera. So put the camera. Yeah, camera is not right. Let's
see, right?
No. It's still you're showing a floor. I mean, we could not see the machine. Show the machine.
You cannot see the machine?
I think so. We should have it in a presentation format so that it's large, Enlarge the thing.
No, I already enlarged it. Okay.
But I can see the machine.
Yeah,
I can see.
Yeah. Okay.
I can see.
Okay. No problem.
Okay, so did you see initially what I show? I wanted to show from here again. Okay,
Yeah, it's better.
thanks with products.
Yeah,
Then
repeat.
shoulders, and then this is the machine.
Mhm.
Here you see a foil, already printed foil, right? And then here is how we produce bodies.
I think there is some problem with the camera. Yeah.
No,
You cannot see video, right?
No.
Sorry.
No, the camera has to be right. You know, there's some problem with the camera.
No, I don't think there is problem with camera. Most probably there is problem with connection.
Yeah.
Do you see now?
Yeah, and there's somebody's coming to, yeah. Now you.
yeah, if there's a suggestion, move it slowly and show the tube.
Yeah. Yeah.
Okay, I will not move at all.
Move
Yeah.
slowly. Yeah. Yeah, now it's visible. That's the laminate forming into the tube.
Okay. Five.
The
Move
same,
really slowly. So
Yeah, now it's okay. Yeah.
okay.
Yeah. Yeah, now you explain. Yeah, that's better. Yeah.
So you see how we make now body. Now we make from here we rewind foil, printed, and here we make body. I will move slowly to the machine. So in this particular machine we have also membrane, top seal, then it's capping, and then tube is ready. Caps are coming from here. Caps are coming from here. And then we do capping. Then I'm going to another side of the machine. Okay. Here is the filling part of the machine. I hope you are able to see.
yes.
So tubes are coming from tube making part. We don't do orientation of the tube because the way they are produced, they are already oriented. So we save orientation on it. One advantage of the machine. And then we do fillings.
So,
Here is the end sealing. And on this particular machine, they are using printed data, so they are not using coding on the tube. Of course, it's possible to have also mechanical coding. But with this printing, you have one more advantage because you may put even unique number on each tube. Because now, if you make this coding on the tube when tube is made, you don't know and don't have information about product. But here, because you make tube, you make codes on the tube information, which is very important sometimes. And then here, we just eject tubes. And then this is not part of the machine. You see, there is one lady here, which is collecting those tubes and then putting in the boxes. Of course, we may also connect static, but in this particular machine, because speed at the moment is something like 50 tubes a minute, they choose to work with 1.100 correct tubes. Okay.
Deepakji, can the focus be on tube formation? Because rest of the things are known. It's basically from the laminate to tube formation, shoulder fusing, side seam. Those are important if that can be shown, once again.
Okay, so I will again shoulders. So you understood we use pre-molded shoulders, right? Okay, so we want shoulders.
The shoulders are without.
And this,
is the shoulder without the cap?
Okay, I will try to open the machine. They disconnected. See, cow shoulders are loaded. And then this is body making.
Yes. So here are the two combinations.
This is sealing conductor. Sealing conductor because this is ABL.
Yes.
And then with rotary cutter. This is just alignment because tube is not loaded 100% here to save time. So we do alignment and then we do sealing.
Okay.
On some machines, we have one in Japan. On this position, you may eject some tubes for quality check if this is required.
Say that again, please.
There is one station which is at the moment empty, but it is possible to do automatic ejection of tubes for a quality check if this is required by customers.
I see.
Okay, here we have membrane on this position.
Right.
And then we have capping.
The next one is the capping.
This is capping, and that's it. There is nothing more. We just make this tube this way. Okay, so now machine stops because for some reason there is no shoulder. As you see, operator was not there. He just came, and then okay. So usually this machine doesn't need a lot of action from the operator. As you see, for all this time, he came now for maybe for a few seconds because there was some error, and that's it. So normally operator is going somewhere and serving machines. So two, even three machines. No need of one operator per machine. So that's it. That's it for this particular machine. Hello?
So for the shoulders, at what speed is this machine moving at?
Sorry, I don't hear you very well because it's noisy a little bit.
What is the output? What is the speed at which the machine is running?
Hello? Can you repeat because I cannot hear?
What is the output speed? What speed is the machine running now?
At the moment, this particular machine is running with these tubes approximately 50 pieces a minute. But this is because of the feeling. This tube is special product, very thick product, so it runs about 50. But normal speed which we achieve usually is 60. 60 tubes a minute, 60. 60 is the speed. And we have another model, and I would like also to my colleague from our factory to join because we have one machine which is not completed yet, but it's in very advanced stage, and he may present you this machine. Can you switch to my colleague? His name is also Miro for a while, for maybe 10 minutes.
There is a question also about long nozzle tubes.
Sorry, I'm going a little bit away because it's really noisy.
There is a
Okay,
there is a question. How would you handle long nozzle tubes with the nozzles?
No, of course, this is method of tooling, but if nozzle is wrong, usually this slows down a little bit the machine because sealing part need to move a little bit longer, and usually we have depends on the length of the nozzle, but you may have 5-6% speed reduction. Otherwise, technically there is no difference. You just really need different tooling to put those shoulders and sealing head, which is also different to seal this long nozzle. We have customers with this type of nozzle. Also, because we have customers in Russia that are using this machine for food products, they're using also another type of head, which is similar to long nozzle, but is with big orifice for kind of paste for food. So yes, though these things are possible with different tooling. Those machines are not universal. I mean, you cannot with one set of tooling run everything. Every time you change something, diameter or type of shoulder or type of cap, you need to change something on the machine.
So what is the diameter range you are able to do? From what diameter?
This particular machine is from 16 to 50 to 50.
Okay.
That's the range of this machine. We are planning to increase range in the next machines up to 63 because we see significant demand for products like shampoo, where customers ask bigger tubes. But the only problem with very big diameters and length is that the machine will also slow down. Every time you increase length of the tube, it's also diameter. This means you increase volume, and because of this, usually filling process a little bit slowly.
There is
yes.
There is a question. Somebody, Mr. Amrinder Singh, wants to show a particular type of tube. So, Indrajit, can you unmute his camera and his mic to show that particular tube he's talking about, which he wants to know whether that can be done on this machine.
Okay.
Indrajit,
okay, please show.
Mr. Amrinder Singh.
Yes, good afternoon, everyone. Actually, we are looking for the machine to operate this kind of tube. We are in thought process to buy. Tube is visible to everyone?
No,
okay.
sir.
Turn your video on. Turn on your camera. We can't see anything.
Now?
Yes, now it's visible.
So this is the tube, and diameter at bottom is approximately 19 mm, and that length of tube is this tube is 88 mm, and this tube is approximately 110 mm. So we are.
I didn't see this. I didn't see.
Is it possible to make such tube on this machine? Then we are interested to know where.
Sorry, I didn't see this. Can you show? Okay. Now I see it.
These look like
yes, yes, very long nozzle. Yes, I see it. And what is on top? Kind of cap, right?
I'm not getting you, gentlemen.
No, it's a cap on the top.
It's having two types. In one having cap, and in other this is means detachable. This can be
Viru, this is something like a pinch off.
Yes,
pinch off.
Pitch off, yes.
Pinch off tube.
Okay.
Seems like a seamless tube.
And
Yes.
how bottom is? Can you show this again? Because this camera is still pointing up and.
This having cap and this is pitch off type.
No, the bottom. He wants to see bottom.
Bottom. I want to see bottom.
This is bottom.
I don't see it. Ah,
It is
okay.
not unsealed.
Okay. So we did something like this. And I think it will be possible to make this. Maybe a little bit lower speed, probably on this particular machine, maybe 40 pieces a minute. But also, as I said, we have new model where we could achieve maybe with this tube, maybe something like 80. But on this machine, which I'm presenting now, I think yes, possible, but 40 probably not.
I can give this sample to Indrajit Chauhan.
Yeah, you give it to that. Mr. Amrinder Singh, you can give this and we will give you the solution. No problem, we can make it.
Okay, thank you.
Yes.
Actually, we are very close to finalize the machine. So if we need to conclude in faster mode.
No problem. You can leave your message in the chat box, your number, we will connect.
Okay.
Okay.
Thank you very much.
We move on to the next part of the
Yeah.
Mr.
Or we can have a speaker first and then we can in between.
I would like to allow my colleague from Gabriel to join because he also is ready to present our newest model.
Okay.
Just maybe for 5 minutes, very fast, because that machine is still not completed.
Okay.
Yeah.
Okay, hi for everybody. I'm Ivan Sastrev and I'm chief engineer in Mechatronica. I would like to present our new project, our new FSS 18. It's a completely new generation machine with a lot of new features, which doesn't exist in the old model FSS 60. Here you can see our new machine. Unfortunately, this machine now is in the process. It is still not completed. Here we have a longitudinal body maker, which can run with IBL and PBL. We have completely new transferring unit. Of course, we have header. This part is heading part, which have to fill the body and shoulder. Cupping station, which is completely universal, and here we can run a really complicated type of cup, like for example this one, which now I should try to show. It's a really complicated caps and similar. Of course, to changing is development. It will be easy for change overing. Everything is done with clamps, and changing parts are really easy easy to remove and easy to load on the machine. Roughly here, back side, it's a filling part, which is not completed. When tube is ready, here on that position, we are transferring the tube to filling rotor, and we are starting. Of course, we have a system for visual inspection. We have a system for like an option system for additional process required. Here should be filling nozzle and filling head, which now are not in place. We are planning to fill end of the tubes with hot air. Marking is in this position, and out machine output should be over there, and here drop over tube flow on the horizontal conveyor, ready to go in the standard cartooning machine. So you can see machine using last generation component for big brands. We are using Yaskawa, which is one of the best company for servo drives. All components into machines are from top brands, and it's very important for machine like that, which have to run 24 hours, 7 days. So if you have some questions, like I told, now I cannot demonstrate this machine because we're still working on this project. Like you can see, not everything is ready, but I hope maximum to 1 month to have some trial runs with this machine.
Thank you, Mr. If there are any questions about,
you can see once again. This one is screen control panel. We have a very good control panel, big screen with a huge number of option interfaces. Very good for operators. Also, machine is, like I told, it's last generation. That means we can connect and we can control from internet. Also, we can upload and download different kind of data from machine. It's for we can put directly in your factory ERP system data from machines, or number of production stops, efficiency, everything that is done. And here we have really good platform, and we can service with different kind of application to improve control and management to machines.
Thank you, Ivan. Thank you. Thanks a lot. Thank you.
Show once again machine. Unfortunately, we have a lot of missing parts. Here should be PBL welding. We should have a lot of things which now doesn't exist, but I think maximum to 1 week we should put all of this, and yeah.
Great. Very nice.
Thank
you.
Panel discussion.
Yeah.
Now yeah, Deepakji, just 2 questions here. One is, what's the changeover time over here from one diameter to another, or what kind of change parts are required, and how much is the changeover time? And
changeover time for this machine now I can't define, because it's machine number 1 from this generation, and we haven't experienced, because no way to define this time just from computers. Machine have to be ready, and we have to test this one. But I expecting about 1.5 hour complete changeover plus running, because here we have it is also depends of product which you have to fill. If you continue with same product, same filling product, of course changeover time should be less. In case you have to clean and to assembly with to continue with new product, it's a completely different story, because we have dirty parts which have a contact with filling product, which have to be clean, have to be disinfected. Here changeover in time is not so easy to define. In case we are talking only for changing parts, that's easy. Probably for 1 hour and 15 minutes operator can be ready. But in case you have to change product, and you have to clean head, nozzles, pipe, all parts which are contacted with material and to prepare with new material. If you include and standard disinfection, of course, it should need a little bit more time. No way to make just for a couple of minutes.
Yeah, one more thing on the PLC system. What's the source of PLC system?
PLC system is
of Siemens or
no, we are using only backoff. Backoff is a PLC system, and all control system is via EtherCAT. It's one of the best protocols for communication between devices. This one is backoff. It's a quite powerful computer for this machine, but it works really, really good. Actually, we are using this type of computer or similar, probably most of 15 years, and just 2 or 3 times we change one input output board. It's really, really reliable.
Okay, and
made in Germany. It's made in Germany.
Okay, and for some of the regulated markets, we require 21 CFR compliant documents for the PLC. Have you done it for any of your machine or in the past?
Actually, till now we didn't do, but I believe in we can do, because in the a lot of our competitors using similar computer, and that means from back of they can.
Could you repeat that? It's coming too softly. Can you repeat that a little louder, please?
Sorry,
cannot hear you very clearly.
About what about the controller. Controller is made in Germany. It's from Beckhoff, and in case you need some special certificate for this machine, I believe in Beckhoff can give us this certificate.
Okay.
There is
okay.
About
what else here you can see? It's a lot of components. I think now it's not so important to show each one, but mainly it's a component from one of the best world producers, and it's a guarantee for long and reliable work on this machine.
There is a question about the sterilization method for the tubes, to clean the tubes. Is there any sterilization provision for sterilization?
See, it's depends of product and depends of the customer. Of course, because like you know, filling in the tube, you can fill many different, a lot of different products. If you we have experience to fill technical grass, to fill some kind of technical product, special diamond pasta, and like this. We have experience with toothpaste. We have experience with medicines. We have experience with food product. Like you understanding, it's quite difficult to. For each one product to have some special to achieve product properties and process. So actually, we have one axis which is prepared especially for disinfection. Type of disinfection could be different. It depends of the product, depends of customers' requirement. Also, filling head and filling nozzle. You are intelligent guy, and easy you can understand filling grass, technical grass, and filling some kind of cosmetic product is completely different. There is a different requirement. That means and filling head is depends of the product.
Okay, I think we should now move to the panel discussion. So thank you very much. You're
welcome.
Nice of you to explain all this. We will just discuss the technology. So we move on to the next part of our program, which is will the new technology help to improve tube pack safety and reduce cost? So for this, we have some eminent panelists. Uh, we have Mr. Ashok Bhatia, Dr. Ashok Bhatia. He's the Chief Mentor on Next Advisors. He's also the board of AK Life Sciences Uganda and Shalby Hospitals and Santis Pharmaceuticals. He enjoys teaching and developing next generation of business entrepreneurs as a visiting faculty to IIM Ahmedabad, IIT Gandhinagar, and IIM Rohtak. Currently, Mr. Bhatia is associated with a few global organizations like Carlyle, KKR, McKinsey, Whitewater as a senior advisor. It's also his birthday, so we want to wish him a happy birthday for today. And along with him, we have Mrinal Banerjee, MK Banerjee. He's the former director, SL Propac. Mr. Banerjee's area of expertise includes product and process innovation, sustainable package design, regulatory compliance, and product stewardship. Current area of research includes effective and custom-built barrier for longer product life, shelf life, touch and feel, dispensation, product authentication, and post-consumer and post-industrial recycling. He's popularly known as MK, and he has filed more than 150 patents globally for SL and already received 54 patent grants. So he's now, he was heading SL Propac's Creativity and Innovation Department, and now he's running his own independent consultancy. Then we have Mr. Rahul Bhargav, who's a former head of department at Ranbaxy, Sun Pharma. He was leading and directing packaging development team for development of novel, cost-effective, regulatory compliant and scalable processes, meeting desired quality standards in order to achieve short and long-term business plans of the organization. Along with his team, he holds a number of patents for new packaging concepts. He's a qualified packaging technologist with over 30 years of chronicle success and significant contribution in packaging industry by creating benchmarks in majorly pharmaceutical packaging. He has recently quit Sun Pharma and has ventured into consultancy in the field of packaging, covering end-to-end pack design, business development, technical services, cost and productivity improvements, sustainability, and graphics and labeling. So with this, we've seen the technology, and I thought we should now be discussing about the adaptability or suitability of this technology in the circumstances against the conventional manufacturing methods and this. And there I thought we can have our discussion in three parts. One is that we need to discuss about the tube itself, the tube geometry, the tube formation, the seal strength, and that part of it. The other is that we need to know how free of contamination and what is the ease of filling, so the GMP aspects, and lastly, the cost effectiveness and logistics saving. So I'll start by asking Mr. MK Banerjee to tell us what he feels about the relative efficacy of this kind of tube versus the conventional tube in terms of its seal strength, shoulder thickness, all that. MK?
Right. The tube made in a mega production center, vis-a-vis tube produced in a small scale, like 60 tubes per minute machine, the difference will be very little, because tube laminate could be same depending on what is the design aspect and product to be filled. So tube structure and the internal layer combination could be same for both mega tube production center vis-a-vis modular all-in-one kind of machine. So there is no difference. Okay. Now the shoulder, there are two techniques. One, as you know, it is online compression molded. So that is also made out of HDP, of course, all food grade and all this. And here pre-molded also it is a HDPE, injection molded, whereas if it is online shoulder making, those are compression molded. But HTP grade and the melt flow index, that changes. But basically HTP property both would be same. Thickness, um, there is a little bit controversial, because they say if it is compression molded, you can optimize the thickness of the shoulder 0.8 to 1.2. If it is injection molded, because it is a pre-molded and dimensional stability is very important, thickness could be little more, but this part is debatable. So I would leave it there. Yeah.
So, any of our other panelists like to comment on this aspect of the tube geometry and tube formation?
No, this part, let me finish that first. This I am talking only for the shoulder.
Okay.
And tube geometry depend on, we call ovality factor.
Yes.
It depends on the laminate.
Yeah.
And more so, post tube production, when the empty tubes are packed in a CFC, corrugated fluted carton,
Yes.
and it is shipped longer distance, how many layer you stacked it, and how is the weight of the tube depending on the diameter. It may happen that the tube deformity comes. Ovality factor is not very concentric there. Whereas if it is a inline, like the machine we have seen just now, it is just, out of the machine mandrel, it conveyed to the next filling station and the product is filled. So there it is little bit much easier, not little bit, much easier. So in terms of seal strength or tube side seam, again I said, it depends on the sealant layer and the polymer grade used. So both could be same, because a lot of tube converter, they don't buy their own laminate. I mean, they don't make their own laminate, they outsource. Big company like SL and other people, they make their own laminate, print, and then they tube. But the smaller and the medium sector, they buy the laminate, outsource the laminate, sometimes printed laminate, and then they form the tube.
So that means that the thickness of the current lamin tube and the thickness of the tube with this process would be identical.
Could be identical because of the deformity part is less sensitive in case of like a inline product filling. So that could be little bit more advantageous. You can go bit thinner.
Yes.
But there is a standardization is there, because post tube filling also there are tests like the burst test, drop test. Those are very important.
Correct.
So you cannot be too much venturous on that. There are some industrial standards on that.
So then shall we move on to discussing, touching on the GMP aspect of this tube? Rahul, you'd like to say something about that?
Well, yeah, definitely. I mean, I have a different, I would say, concern on this technology. Maybe we can get some clarity over here. The thing is, see, pharma companies, I've been in pharma for over 30 years. So the focus of pharma companies is purely on the formulation, number one. And they want the simplest way to make the packaging. Like here, currently they get a ready-made standard tube. They just fill it, seal it, and that's it. And many times the production people, they want even the batch details to be pre-printed. I mean, they are so scared that any change, these kind of things also, they're scared that they can have market complaint of ink rubbing off, or wrong batch details and all. So they want to play as safe as possible. See, I'm talking all these things from the experience what I have, and making them do even tube formation to me is asking too much from them, because they are used to getting a tube, fill it, seal it, and of their line. Now, yeah, so it's a tough thing for them to employ people who are experts in shoulder fusing of shoulder or side seam and other things. So to me, I mean, it's a tough thing. And
So that's a
how
question.
many of them will be interested in these kind of things? That's one area that needs to be looked after by technology providers. That uh, I've raised a very what I've learned and what I've seen on shop floor. They would like to have the simplest thing. So here, while there are advantages, but this is the biggest thing that how do we expect a pharma company to know because see, SL is there and Skypax and other their main business is making tube. So they are expert in making tubes. Now telling a pharma company to make a tube, suppose they have a product and for B product they have a different structure. Now they have to do experiment and see that that structure is fusing onto the HDP shoulder, sealing is all okay, there are no leakages and other things. So I mean, that's one area which I feel the technology provider should focus on. That's mine. I mean, while we come to GMP and other things, but this one area I thought we must
address this to Mr. Mirusa, whether the technology of shoulder fusing requires a great amount of skill in this machine. That's what you're saying.
No, not really.
Yeah, since everything is automatic, yeah.
Yeah. And another thing is, I would like to add that, the shoulder making is already the people are buying from the people who are having the injection machines. This is a pre-molded shoulder. Pre-molded shoulder injection molding is a very renowned, very technology which is there for the same technology. You make a cap and you make the shoulders. Right? These are the two simple things are there. Only benefit what the pharma company will have, they can have their printing done on their laminate and they can launch their products with their own supervision. Laminate, as MK has rightly says, most of the tube manufacturers are buying a laminate from an outside, either Huhtamaki or PPL or all the people, except SL or Srirama. Other people are buying a laminate or Skypack maybe making some laminate.
Yeah, that's true. See,
Yeah, Mr. Baga, I'm Arvind Narang here. Here I would like to add a bit. This is not a big rocket science. I agree with your concern about the seaming and shoulder welding. See, for the tube making machine, it's like an extension of tube making. So you require a training of hardly 10 to 15 days and guy can be perfect. So it's not a big deal. It's an automatic machine. Once the setting is done, once in a while you have to do the inline checking. But it's not a difficult thing as you think. Of course, you are very well experienced.
I think, Rahul was possibly talking more of the psychological aspect of it.
Yeah, you're right.
Pharma company operator will feel that this is outside his domain. So he would probably want to.
Yeah, and then how many people are you going to train? I mean, there'll be one shift. If you're running 3 shifts, so then you need
one operator per shift is required. So automatically there we are ready to pitch in. Bhagav sir, don't worry, we'll take onus of that.
Okay. Yeah, that's fine. I see this was just one concern which I thought if we have it discussed, then it will be easier.
Sure.
I mean,
you have a valid concern. Of course, the focus is on pharma.
You will just make your comment about the GMP. We are running out of time, so I'm rushing. Yeah.
Yeah.
Another thing. Want to say something? Yeah.
Okay.
Yeah, I think while I appreciate that Rahul's concern are valid, but what I would say is that any organization, when they want to switch to a new technology, they will certainly weigh the advantages versus the challenges they have.
Yeah.
And I think from the demonstration that we have seen and from the presentation that I've gone through, I think for pharma industry, the biggest advantage which they would look forward to is the GMP, the contamination-free formation of tubes or any product for that matter. Okay, today you have no control on somebody's making laminate, somebody's making tube, the tubes are being transferred, the way they are being packed, the way they're being stacked in your godowns, etc. So you have multiple controls at various points. Here, at least one thing is there, that number one, tube is being made in-house and there's a very little time between the tube making and tube filling. There's hardly a fraction of a second. So therefore, that contamination-free filling probably could be a label given to this machine, which I think any pharma industry would be very, very worried, given the fact that today you have to, even there's a lot of export which is expected from India. So that's one thing I see. There are some concerns which I think if I have time, I can put now. But from the benefit point of view, I see a pharma industry once weighs this major advantage, those things of training, etc., will then look a bit smaller. I have a couple of concerns, a couple of questions, though I'm not a technical person, but one is that, the temperature control, because see, the pharmaceutical products are highly temperature sensitive. So I didn't understand that there is any, well, the tube is manufactured, it is a temperature required, heat is required to make the tube. And between the filling and that, whether it's a cooling system or whether it is not required, I think Mr. Rahul would know better. So that's one thing. And the second is the tube in pharma, I'm told, is there are more collapsibility is very important, because you don't let air to come in once the drug or medicine comes out of it. So whether the kind of material that it will be able to create, of course, there's a laminate which you will be putting inside. So there's a second question which I think needs to be answered. And third, I think Rahul already asked sterility, because I think a lot of ophthalmic products also are going to tubes. Whether those products will be possible to make here from the international GMP point of view are some of the questions in my mind.
I think MK could also answer some bit of it, and then probably Miru can also say something.
Miru should answer it in terms of the hot air sealing. I think that is very common, and last time Miru confirmed that they use generally hot air technique for the end sealing. Yeah. Whereas side seam and the shoulder, it is a combination of hot air, and also side seam they use high frequency with a magnetic band there.
Now,
so it is
MKG,
indirect heating.
Dr. Bhatia is asking, after the tube formation, there is a product filling. So he's asking that when the tube is formed, it's a little bit hot. And when you're going to fill the product, so is there a cooling mechanism which can bring the temperature down when the tube is formed and prior to filling?
Yes.
Let me talk a little bit, Theo, about some concerns. I'm showing, I don't know whether you see all the time the machine, because one concern was how difficult it is to operate. There is only one operator that is operating this machine.
Okay,
and we need to
Dr. Bhatia raised about,
but I don't see big problem. Hello.
Yes.
Regarding tube, do you hear me?
Yes, we can hear you.
Okay, regarding how hot the tube is. No, tube is not hot. Sealing is only in the side seam area. This is small area. Usually overlap is hardly 2 millimeters. So you have slightly increase of the temperature in this area, probably 40, 50 degrees, but the remaining part of the tube is with normal temperature. So tube is not hot, and we never had this kind of problem to need any cooling of the tube.
The shoulder is hot at the time of fusing the shoulder to the body of the tube.
Shoulder? No. Shoulder is, in order to seal tube shoulder to the body.
Yes. Is there a heat applied then?
We melt something microns. But it is very small part of the shoulder, also 2 millimeters wide, and in deep is about 50 microns. 50 microns, total thickness of the shoulder is minimum half a millimeter, sometimes even more. So from the side which is in contact with product, you don't have any practical temperature increase, maybe 1-2 degrees, but nothing which is of any concern. So this problem is with tubes that are made with compression or injection molding. Therefore, we are not using compression molding for NFS machines, because if you do compression molding, then of course shoulder is very hot and it needs seconds to cool down. But there is even a bigger problem there. There are kinds of gases that are separated from the shoulder during injection, so you cannot allow filling to be done immediately. But with pre-molded shoulders, there are no problems with that, neither temperature nor any other issue. Also, I would like to pay attention on the thickness of the foil. It was mentioned that there will be no difference. No, there is difference because the approach which we are having here is different. We are making body pulling the foil. Pooling means we can use significantly thinner material. So this is one reason why we claim we can use 120 microns, maybe even less. Second reason to claim this, and this not just claim, we've proved this. There is one machine with this thickness, is that tubes are immediately transferred from the
Yes.
on which they are made into the colder where they are filled. So there is no problem with ovality. Ovality doesn't really matter here. And foil thickness is not a problem. If you see Canada, you see how simple tubes is transferred. So even if it is very thin, there is no problem to transfer, which was in fact first reason why we started developing these machines for Unilever many years ago. They wanted to go to very thin material. Okay, it's another question whether customers will accept such a thin material, but thickness is much less on this type of machines than on normal tube making machines. And also regarding hygiene, this is really maybe a main advantage of this machine. We have one big customer in Japan, First Star. These machines in Gabo, in the factory, are made for them again. They have also other machines.
So I think Mr. Bhatia does that.
Our machines, they are not going to use any other technology than FFS because of this, because there is no storage, no transportation. You see here, these guys, they have only boxes with shoulders and cap, no more. Everything is made on the machine. Okay.
So does that cover your concerns, Mr. Bhatia? And would you like to sum up your observations?
Can't hear you, Mr. Deepak.
Yeah, I said the concerns that you had expressed. Does Mr. answer sum up your concerns? And would you like to make your observations, final observations?
Yeah, I think these are the questions, of course, because these are something in pharma industry, you have to specify, at what temperature is being filled and what temperature is the product, etc. You have to put in the dossiers, etc. So I think those questions are there. If they are confident to answer, I think while the user will certainly like to know those details. Right. And that's it. Otherwise, I think the advantages I see are certainly more than the challenges that we have, because obviously one expects that when they made a machine, and they're trying to put into pharmaceuticals, those concerns of regulatory, those concerns of temperature, concerns of hygiene would have been taken care of. If not, those questions need to be verified or validated.
I got a comment from Mr. Himadri, who is also on this program. He's as we know, any of us might be knowing him. He's an experienced packaging expert from Ranbaxy. He says inbuilt tube in pharma manufacturing is like milk getting packed in a form-filled seal sachet. Dairy scientists were not packaging people, but today packaging is integral part of dairy. Likewise, tomorrow tube and pharma will get married. It's a question of adoption. So that's
absolutely.
MK,
I agree with him.
I agree with him. MK?
Yeah, it is an unanswered, I think, that part. So there is no confusion in that offline mega center versus inline. So I wanted to come back on the temperature part. As I said, it is high frequency and with the indirect magnetic band. When the foil goes through the magnetic field, in that instantaneous temperature happen, and when it passes through the cooling jaws, immediately the temperature come back to normal. So you can touch it. In fact, we are daring, in old days, but now it is not allowed because of safety and all this. As soon as it's come out of HF band, high frequency band, you could touch with the fingertips. So it is normal temperature. Shoulder also, it is a compression molding, it is a hot melt around 210 degrees C melt temperature. And with the donut like a ring, it falls. And then immediately the ramming happens. And the matrix, it has a chilled water, around 18 degrees, 15 degrees C. So when the shoulder comes out of the machine, that also you can touch. So these two I wanted to clarify. It is true for this machine also, and moreover, it is a pre-molded shoulder. So it's much better than the compression. So it is added advantage. And lastly, the hygiene part. When the tube is made before ophthalmic, how to sterilize that. So this part there is a different model, but one thing is common for both. So all these the pharma ophthalmic is more. It has to be made in clean room. Even the pre-made component, the shipping mechanism, and also when they do that, it has to go through sterilizing chambers and all this. And the entire production unit has to be clean room, class 10,000. So that is very important.
So
That's all.
MK in this, in this technology, if you see that, the cleaning is much more easier than making a tube. You can clean the laminate in a better manner than to cleaning a tube. Because in this case, if you have a
Yes.
So we have
That's true.
we've touched upon the tube making, we've touched upon the GMP. Would somebody like to talk about the logistics benefits that you may have? You are moving a pre-printed reel into the factory. You're saving on warehouse space. You're saving on transportation. So, Bhatia, would you like to say something about that?
I think that is very obvious, of course, that you are saving a lot of logistic and therefore the problems because of logistic. But more than that, what Praveen said earlier is, I think, both in new product launches, being a marketing person, I can say that, and exports. Many a time you need to cater to small orders. And the tube manufacturer, particularly when you go to them, there's a minimum MOQ of a lakh, 5 lakh, 10 lakh, etc. And the pricing is accordingly done. So I see that probably an advantage, that your only investment is in laminates, and you can then accordingly run as many tubes you want to run and fulfill the orders. And you also don't have to pressurize your buyer on the MOQs, because if you are exporting something and if you tell somebody you have to buy minimum 1 batch or so, I think those advantages I see from the business point of view are very many here. On contamination, and saving on. And the other thing is pilferage. Because we also have experienced that, when the brand becomes very big, there are equal number of products which are in the market, which are similar looking, or maybe at times the same products. So we don't know whether the same tube manufacturer is playing mischief or somebody else is trying to duplicate. In my previous company, we had a 150 crore brand in a tube, and we had a serious problem in duplication. And one reason for the decline of the product was the marketing guys would say that we are being duplicated in the market. So I see that a tremendous control can be had in this setup, because you are controlling everything yourselves. You can't blame anybody else. So these are the few things which I see from the business point of view. And apart from it, you can also claim. See, another thing is, in business, nobody will see the tube differently. A customer will see the same, the doctor will see the same. But when you are detailing to a doctor, telling to a doctor and tell them, this is how we make the tube or make the product in a condition, I think is very impressive. It can be a very good marketing point for the customer. You can differentiate your product as compared to other products, which is very important in pharma industry. And that's how the big brands are created.
Thank you. That's very well. The brand integrity issue comes
very
up.
important.
I think we are run out of time now, so I don't want to tax everyone's patience. We should wind up now, and I would invite Mr. Vinod Kalani to propose a vote of thanks for this webinar. Mr. Vinod Kalani.
Is there? I suppose he should be there.
It was quite an interesting session today regarding in-house technology to manufacture tube. Everything made on one machine. So from GMP point of view and from upgrading the overall affairs, this seems to be quite interesting. Then it all depends, as mentioned by all our panelists, that what kind of GMP benefits we can have, what kind of marketing strategies people have, then what kind of cost benefits we can have overall. That is also very important for any industry. The costing part is also important. The cost of the machine, and other support system because this seems to be quite, a sophisticated machine. So I find it quite interesting. But it all depends, from the user's perspective, and what kind of product they want to fill upon this. What is the volume? What kind of pricing? What kind of costing? All these factors are very important, as Mr. Rahul Bhargava also, mentioned about his experience, that adaptation is very important. Changing the mindset of people, because it's very easy to buy tubes and just fill it up, things like that. So overall, it was a good discussion, and our thanks to all the panelists, and our thanks to Mr. Miro and the people from Bulgaria who have presented their machine. I saw the pictures of the country. It's quite a beautiful country, and I congratulate all our people who have put up this show along with folk. So I'm very thankful from our organization to all the participants who have spent so much time to understand, to learn the new technology. And I think this has got a good, starting point. So this has to be built in.
Yes.
The interest will come up once, these kind of queries are addressed, of the technocrats, of the people working on the shop floor. So our thanks to Mr. Miro, the other participants, the panelists, and the organizers. So Mr. Sikri has been very active, our chairman, and he really takes interest in putting up such webinars and such seminars for the benefits of the overall industry, not just our manufacturers, even people on the shop floor. He keeps on organizing such shows. So thank you, Sikriji, and thank you for involving me and giving me this chance to be part of this elite group. Thank you very much.
Thank you very much.
Thank you.
Close the event. Thank you very much for everyone.
Thank you. Thanks a lot.
Thank you, everybody. Thank you.
Thanks, everybody. Thank you. Thank you. Bye.
Bye.